Welcome. So from today we will begin with collections in Java. This will be a long journey and a fun journey too. The reason being, collections makes us lazy. As a programmer, we always find things that makes the programming easy, correct? So collections makes programming easy for us programmers. So it will be a fun journey all around, fine? So let's begin with collections in Java. So to understand what collections does in Java, let's just do a simple program, okay? Just a small program. So what we are doing here, we are simply creating a linked list. We have already done this. We are creating a push method to add elements in the linked list, and we are creating a get count method to get the size or the count of elements in the linked list. Okay, this is our main method that is calling these functions. This is a linked list, that is a class name that we have created. List is a reference variable. New linked list here creates our object. Fine. So when we list.push 1, so 1 will be added into the list. List.push 3, 3 will be added. We have already done this. Okay. So what we are doing here, we are simply creating a linked list. We are simply creating a linked list. Fine. So suppose I have a linked list here. This is one node. Okay. It is pointing to the next node. It is also pointing to the next node. So suppose it is 1 3 1. Okay, the first three nodes that I am pushing, 1 3 and 1. Fine. Then we have 2 and 1 also. Okay, 2 and 1. So these are the 5 nodes that I have. Fine. So when I push these nodes and call the get count function, it will return me simply 5. It will return me simply 5. So what we are doing, we are simply creating two functions for adding the element into the linked list and getting the count of the elements in the linked list. Okay, so as a programmer, linked list is just a basic data structure. It is a standard data structure. Okay, anything that we have to do in the linked list, we have to create these methods by our own. We have to program them. Okay, to add, to count, or to delete anything, or to insert. So we have seen everything in linked list. Okay, so we have to create these methods ourselves. What collection does, collection makes us lazy. Collections provide these functions to add the element, to get the size. Let's just do a simple program in collection, the same program to add and get the size of the linked list, and to add the element, the same program, and see what is the difference. So in this program, what we will be doing, we will be using collections to do this, to do those two functions, that is add and size. So we will be using a linked list class that is present in collection framework. We will be learning about this thoroughly in future videos. Okay, we will be calling string. This is my type parameter. So the prerequisite is generics, and wrapper class is auto boxing unboxing for watching collections. Fine. So list is my reference variable, and suppose new linked list. Okay, so we will be learning about linked list thoroughly in future videos. For now, just think that this is simply a linked list. Okay, so now what collection frameworks provide me is simply methods. So list.add, and I will add, for example, prep. So prep will be added. This is a string. We have passed the type parameter as string, so there is no issue. Then list.add again, and so for example, now I type byte. So prep byte. List.add, I will add a numeric string. So for example, 10. Okay. List.add again. For this time, let me add 50. So these are the things I add. Let's see if they are added or not. So sout, that is system.out.println, I will simply pass list here. Okay, this is so simple to add elements when we are using linked list as a collection. Okay, so using collection framework, see what I have done. Just use just 4 lines, and I have added prep byte 10 and 50 in my linked list. Just 4 lines. Okay, and just a single line in that too on sout list dot size will give me the size of my linked list. So that's why I was saying collections makes us lazy. We programmers wants to be lazy. We need these methods, dot add, dot size. See, that is so simple. Okay, we have just 4. The size of the linked list is now 4. So 1 2 3 and 4. So as you can see, this is what we will be learning. Excited? I am excited. This is what we want. This is dot add, dot size, dot remove. This makes programming simple for us. Okay, so now from now I will be beginning with, so this was an introduction to why we need collections. Okay, now I will be beginning of what are collections. So these are the points if you want to take down. So standard data structures do not have any ready-made method support. As a programmer, we need to implement every method when using standard data structures. Okay, we have seen this. If you want to search, sort anything, we have to write those programs. But collection framework, on the other hand, provides us with plethora, that is many of ready-made methods that we can use while programming. Okay, so this is what the need of collection. Now let's see what is a collection framework. So if we want to represent a group of individual objects as a single entity, then we should use collection. Okay, so if we want to represent a group of individual objects as a single entity, fine. So if this is my collection, so it will simply contain a group of individual objects. This will simply contain a group of individual objects. So for this purpose we will use collection. Okay, if there are many objects that we want to store, they can be heterogeneous, they can be homogeneous also. So in that case we will use collection. Now let's see what is collection framework. Collection framework defines several interfaces and classes which can be used to represent a group of objects as a single entity. So to represent collection, we use collection framework. And what collection frameworks provides us, it defines several interfaces. So it is very important that it defines interfaces and the implementation classes of these interfaces. Okay, now what are interfaces? We have explained you properly what are interfaces before. Okay, so what interface provides us with some abstract methods, so what these methods does, so what interfaces does, it provides us with abstract methods, and these methods are nothing but some type of contract. It is some type of contract that every class that will implement these interfaces have to have the definition of these methods. Okay, have to implement these methods. Every class that implements these interfaces have to implement these methods. Okay, so we have many interfaces in collection. I will explain you each interface. Okay, so why these methods are provided in collection? There are some methods that are very common. Okay, every collection class, that is if you are talking about array list or we are talking about linked list, there are some methods that are very common. For example, add method, if you want to add some element into a list, if you want to delete an element from the list, okay, from the collection, or if you want to get the size. So these methods are very common. If you want to know if the collection is empty or not, so these methods are very common. So these methods are provided in interfaces. Okay, and every class that implement these methods, these interfaces, has to implement all of these abstract methods. Okay, so we have interfaces and we have their implementation classes. Now we will see the types of interfaces that we have, the implementation classes one by one in our collection framework. So the first interface that we have is collection interface. So if you want to represent a group of individual objects as a single entity, then we used collection. So I have told you this before in the last slide. If we want to represent a group of objects as a single entity, okay, so we have here our group of objects and we want to represent them as a single entity. So in that case we will use collection. The next point is, this defines most common methods which are applicable for any collection object. Okay, so in collection interface we have these methods that are not implemented but only defined. They are implemented by the classes that will implement collection interface. Okay, so all the methods that are defined here are most common methods that are used by any collection object. Okay, few of these methods are add. So if you want to add suppose s5 here, so we will use simply add method. Okay, our reference variable, for example, l.add. If I use this l.add and 5, so it will add 5 here. Fine. The next method is remove. So if you want to remove suppose s3 from here, then we will use remove method. Correct? If you want to remove this s3, then we will use remove method. Then contain. If you want to check that s2 is in the collection or not, if you want to check that s2 is in a collection or not, then simply use contain method. We will see all these methods during the class implementation. Fine. So when I take a coding example, then I will use all these methods. Then remove all. If you want to remove all the elements, that s1, s2, s3, s4, if you want to remove all these elements, then we will use remove all. Then next is empty. If you want to check if your collection object is empty or not, okay, if your collection is empty or not, then we will use isEmpty method. Simple. The name says it all. The name says everything. Okay. Size, if you want to get the size of the collection. So these are few methods. There are more methods also. Okay, there is one method known as iteration. So what iteration does is, if you want to access these elements, that is s1, s2, s3, s4, and we have added s5 also. If you want to access these elements one by one, that is iterating through the collection. Okay, access these elements one by one, then what we will do, we will use iteration. So iteration is a part of cursor topic. Fine, we have three iterators in collection framework. Okay, so when cursor topic will come, we will talk in deep about iterators. Okay, so iterators are used to access the elements in a collection one by one. I will remind you again, these methods are not implemented in collection interface. We do not implement methods in interface. These are abstract methods. they will be implemented by the classes that will implement these interface. Okay, now the classes that extends, we do not use the word extend, we use the word implement. Interfaces are implemented. Okay, so these methods will be implemented, their code will be in the classes, not here. This just defines a blueprint that these methods has to be there in those classes. Okay, every class that is a collection class has to contain add, remove, contain, remove all, is empty, size, and there are more methods also in collection interface. We will see them. Fine. So the next is map interface. So we will be learning about collection interface and map interface differently, because these two are different things. They have their child interfaces also. So sometimes people say that collection is a root interface, but that is not entirely true. Okay, because map interface does not come inside collection class. Okay, sorry, collection interface. Collection interface has a different, and map interface is different. So we will divide our course into collection interface and map interface and their sub interfaces. Okay, so we have seen now what is a collection interface. Now let's see what is a map interface. If we want to represent a group of individual objects as key value pair, then we should use map interface. Okay, as key value pair, there was a single entity, individual objects as single entity, but here we have a relation between these two objects, that is a key value pair. Okay, so for example, 101 Tony, 102 Steve, that is a key value. 103 Thor, 104 Bruce, Bruce is Hulk, so most of you knew. So key value. Okay, key value pair, then we will use map interface. So both key and value are object, so these two are objects. Duplicate keys are not allowed, so these keys should not be duplicate, but values can be duplicated. Okay, so keys should not be duplicated, but values can be duplicated. So few of these methods are clear. Okay, if we were to remove all key value pairs from invoking map, contains key k. So what it does, it returns true if the map contains key k. Okay, if I want to search for 103 and if the map contains key 103, it will return me a true. If I want to search for 105, it does not contain 105, so it will return me a false. We will obviously see them during when we code in map interface. So contains value, if it returns true if map contains v as a value. So if I search for Steve, so it should give me a true, but if I search for example Barton, that is Hawkeye, it will return me a false. So get k, it returns the value associated with the key. So if I send key 104, it will return me Bruce. If I send key 101, it will return me Tony. Fine. Then it is empty. If we want to check that our map is empty or not, then we will use is empty. There are many more methods. These are just few examples. We will see all the methods when we will learn map interface. Fine. So first we will see collection interface and then we will see map interface. So now let's see collection. So in the collection interface, the first sub interface of collection, that is the child interface, that is list interface. The second one is set interface and the third one is queue interface. Now let's see the difference between what is a list interface, set interface and queue interface, and then we will move on ahead in these interfaces. Okay, we will see the implementation classes of each one of them. So first let's see the difference in these three interfaces. There is a child interfaces of collection interface. So collection, where duplicates are allowed and insertion order is preserved, then we should go for list. If we want to store objects, individual objects as a single entity, that is the definition of collection, where duplicates are allowed and insertion order is preserved, then we should go for list. Okay, so what do you mean by duplicates are allowed? So it's actually very simple. So if I want to insert 8, 9 and 8 again, so the duplication is allowed, then we should go for list. Okay, and the insertion order is preserved means if I insert 8, the first 8 will be inserted, then 9, then 8. If I print it, so 8, 9, 8 will be printed. That is the insertion order is preserved. Now let's see what are sets. So set interface is again a child interface of collection. So collection where duplicates are allowed and insertion order is not preserved. So in such cases, set will be used. So insertion order is not preserved. So in set, duplicates are not allowed. Fine. And the insertion order here is not preserved. But in list, duplicates were allowed and the insertion order is preserved. So how it is preserved, we will see in list, and why it is not preserved in set and the duplicates are not allowed, we will see when we learn deeply in set interface. For now, just see the difference between these two. And what is queue? Queue is if we want to represent a group of individual objects prior to processing. Now what is the meaning of prior to processing? Let's see. So here what we want to do is we want to send mails. Okay, for example, I am mailing 5 persons. So M1, M2, M3, M4, M5 are the 5 people's mail IDs that I am mailing to. Correct. So before I am mailing, mailing is my process. Before I am mailing, so prior to processing, prior to the process of mailing, I am creating a queue. I am creating a queue of 5 mail IDs. I'm creating a queue of 5 mail IDs, and the most important point is that insertion and deletion in queue. We insert from the beginning, okay, and we delete from the rear. We insert from the rear and we delete from the beginning in queue, correct? So when M1 is first inserted, then M2 from the rear is inserted, then M3, then M4, correct? And when we delete it, when we access it, we access the first element, okay? That we delete from the front. We delete from the front and we insert from the end, correct? So this is what prior to processing means. We are creating a queue, and the sequence is important as it is FIFO, first in, first out. So first in, first out is maintained in queue, correct? And we will see more. We will see in detail why only queue is used in this scenario. Why not set and list are used? So as you can see in set, we can see why set is not used. We will also see why list is not used in this scenario. Why only queue is the most optimum approach when prior to processing occurs, correct? So this is the difference between list, set, and queue. Now we will deep dive into list. Then we will see the implementation classes of lists. Then we will go to set. We will see the implementation classes of set, and we will go to queue, and we will see the implementation classes of queue. Okay, this will be the approach. First, then we will at that point the collection interface will be completed, and then we will go to the map interface. Okay, and then we will see the tree there. So this was collection, list, set, and queue. Let's see now